we'll be having two major sessions. The first session will be about theoretical aspects of NoSQL, NewSQL, and PolyStores. But I will not dive more into this because there is a separate seminar session dedicated to this kind of talks about NoSQL, NewSQL, and PolyStores. So I will let you cover the remaining parts of this chapter, but I will mainly emphasize on what NoSQL is, what NewSQL is, and what PolyStore is. And after discussing this, I will be shifting the more to practical aspect and then discuss or practice on some of the PL/SQL object-oriented database scripting techniques. And if possible, I'm not sure if you can achieve that, but we can also discuss about database connectivity, since you need database connectivity for your project. But mainly we'll be covering the PL/SQL aspects of our lab session, and then the object-oriented aspects of our lab session. But the remaining one would be extended forms of PL/SQL, which are mainly about database links, database connectivity, and we'll be using Java for database connectivity, just to showcase how you can connect with Oracle database. It's a simple procedure. Maybe we will see that in the next slide. So coming back to the theoretical aspects of this course, which is about NoSQL, NewSQL, and PolyStores. Today I will talk about the motivations behind this talk, specifically pertinent to NoSQL, NewSQL, and PolyStores. When we see the trend, for instance, the main motivation for such kind of talks or such kind of technologies like NoSQL, NewSQL, and PolyStore technologies is mainly driven by or dictated by the uprisal of or the down of big data. And big data is usually characterized by unstructured set of data and a very high degree of interconnection. It could be hyperlink based interconnection, or it could be tags based interconnection for like XML type of databases. It could be blogs, it could be some intermediary social media network analysis, memory leaks. But this kind of things, like the trend regarding big data, the trend regarding interconnectedness of data, the trend or the requirement of high scalability that come along with the existence or the appraisal of big data brought the necessity of building or developing a technology called NoSQL. Okay, and the other motivation would be limits with the existing relational database management system or SQL language-based database management system. When you see, for instance, relational database management system, for instance, even from the pedagogical aspect, we do have a database administration separate course for relational database management systems. This is mainly due to the fact that relational database management systems are a bit sophisticated and their management needs some set of skills which is a bit different from database programming and other aspects. So for that specific purpose, there are limits with relational database management system. The first one is from the skilled manpower perspective. The second one is you need to define schemas, or you need to articulate schemas in in a perfect way, at most. So that is one limitation. SQL by itself is one limitation. We have been discussing about how declarative SQL is. So complex fine-tuning, optimization of queries is hard in relational database management system, because we have seen that when we talk about distributed database design, especially from vertical fragmentation, horizontal fragmentation side, we distribute databases, one for scalability and availability, the other one is for optimal use of data. So from that perspective, optimizing those distributed relational database management systems is a bit hard. So that could be mentioned as the limitation of relational database management systems that gave birth to the existence or the the existence of NoSQL or similar type of database management systems. The other one, scalability, I have already mentioned this one. In case of relational database management system, for instance, if you consider parallel relational database management system, these database management systems use a shared disk for online transaction processing. So this could be also mentioned as a problem. The other motivation behind NoSQL and similar type of data is the CAP theorem. When we say CAP, it means consistency, availability, and partitioning tolerance, CAP, the CAP theorem. So I think in the early days of database design, database management system development, people from University of California, Berkeley, and MIT came up with this idea called the CAP theorem, and they said no one distributed database can achieve 3 of these properties. It might achieve only 2 of these 3 properties. That's their hypothesis. The hypothesis was first raised by a guy from or a professor from University of California, Berkeley, University of California, Berkeley. And from that university, they proposed this hypothesis in the first research conference related to database management systems. And then a couple of years after, a guy from MIT proved it in a separate conference, and it became a theorem. And from that time afterwards, it's given a name called the CAP theorem. The CAP theorem. So in this CAP theorem, they said any database management system can only achieve 2 of the 3 properties. What are those 3 properties? The first one is the consistency. The second one is the availability. The third one is partition tolerance. Okay. So this is one thing. For instance, if we achieve partition tolerance, okay, if we achieve partition tolerance, then we might have to trade off availability or consistency. That's one thing, okay? Partition can go with only one of these 2 properties. So these are the motivations. The first one, the existence or the developments regarding big data and interconnection of data, scalability of data, which are more related to big data. The second one is the limits of the existing, the most popular, the most dominant database management system, which is relational database management system. And the third one is the theorem, which is the CAP theorem, that gave birth to the existence of NoSQL or NewSQL or even PolyStores. So I already mentioned what the CAP theorem is, but the controversial topic here would be the guys who came up with this hypothesis of CAP theorem they said a database can't provide consistency and availability during a network partition. That means if you have a partitioned network or a partitioned distributed database management system, you know what partition is, right? So if we have a partitioned database management system, then we cannot provide both consistency and availability on that partitioned or network partitioned environments or network fragmentation enabled environment. You can only achieve either availability or consistency. So it's a polemical topic because it's subject to discussion, or it's very controversial. One can say I can achieve consistency and availability preserving network partition, but in practice that was not possible at that time, but it's still subject to debate by the research community. Okay, so that's why we say it is a controversial topic. So actually this is the most important thing when we talk about NoSQL database management systems. Okay, so some people might refer to it as a factor for scalability, but it doesn't directly align with the concept of scalability. Just here we are talking about the trade-off between consistency and availability, mainly within a partitioned network environment or within a database management system which is network fragmentation enabled. So from this perspective, there are two important points, or different points actually, to view. The first one is from the relational database management system perspective, and the second one is from the distributed systems perspective. For instance, whether it is distributed database system, or whether it is distributed relational database management system or distributed NoSQL database management system, there are two views of transaction, or these three characteristics of the CAP theorem. When we come to relational database management systems, or relational database systems in general, consistency is a very essential one. We have been discussing about this one. ACID is the most prominent property of relational databases. But when you come to distributed systems, mind you, it might be even distributed relational database systems, the most prominent requirement, in addition to consistency, specifically for the relational aspect of distribution, is availability. Okay, so we do have two things which may not go hand in hand, or which may not complement with each other, but that's a problem in the area, or in the arena. Okay, so we have to deal with these two things, and the effort to deal with these two things give birth to the CAP theorem, and give birth to the NoSQL database management systems. So as I already mentioned, the CAP theorem is a desirable property of distributed system. It's a desirable property. It's not necessarily an achievable property of distributed system, but it's a desirable property of distributed system. So what are the desirable properties of distributed system? The first one is, as I already mentioned, consistency. The second one is availability. The third one is partition tolerance. What does it mean? When we say partition tolerance, it's to mean the system keeps functioning in case of network failure. What does it mean again? Assume we do have like 5 partitioned segments or fragments of a single table. Assume it's distributed over the network, so it's network fragmented. And then from those 5 fragments of that network, the fragments of a given table, then we might be replicating each of them to a separate 5 other sites. So partition tolerance means whenever the first 5 or part of the first 5 nodes fail, then the replicated nodes of these same fragments will substitute the functionality of the original fragments, network fragments, and then the system keeps working. So that's partition tolerance is directly referring to that aspect, or that concept. But when we come to availability, it's directly related to reliability of the system, So when we say availability, all requests get an answer. It's desirable, right? For instance, from the time you, or from the total frequency you try to access your CBE mobile bank app, how often did you succeed? That's a description, or an functional figure to describe what availability is and what reliability is. Okay, so in this context, since we are talking about desirable properties, ideal properties, we are saying availability is a measure of how often do you get successful requests, or requests that got some kind of response from the vendor, from the server. The third one is consistency. That means this is the desirable property of any distributed system is to have a strong or a strict consistency. That means all nodes see the same data values at the same time. So if you replicate one segment or one fragment of a table to, say, 10 different locations in Ethiopia, for instance, then every people accessing those different replicated data components or fragments should have the same view of the data. There should not be inconsistent view of the data, even though they are accessing data from different but replicated fragment of a table. So let's relate this concept of the CAP theorem with the history. As I already mentioned, it was first raised in the early stage of NoSQL database development in 2000 Gregorian calendar, GC. I think Brewer, the guy called Brewer, came up with this conjectures. When we say conjectures, it's a trade-off operation that says either you can satisfy consistency and availability, or partition tolerance and availability, such kind of conjectures. Okay, so the CAP theorem can be further elaborated in terms of conjecture operation. So he came up with this idea, okay, of conjectures that one can only have true properties of this CAP theorem at the same time. And then in 2020, in 2002, a couple of years after, Gilbert and Lynch from MIT, they proved the conjecture, which becomes a theorem called the CAP theorem. So we have been talking about consistency, right? So there are two types of consistency. We have covered this one in our previous lessons. The first one is strict consistency or strong consistency. We also refer to it as acid property, or a transaction with acid property. Okay, so here all nodes see the same data values at the same time. This is a desirable property mentioned in the CAP theorem here. But the second one is eventual consistency. So in case of eventual consistency, some nodes may see different data values at the same time, but the main important thing here would be not making the database consistent synchronously, but trying to make the database consistent asynchronously, preserving high degree of availability or scalability of the database management system. We can illustrate this one from the symmetric asynchronous replication perspective. So when we say symmetric asynchronous replication, we are referring to a distributed database system in which each database management system can trigger update and also can trigger update in its entirety, like in its jurisdiction, and also can push or can propagate those updates made to it to other nodes in the database management system. That's why we call symmetric asynchronous. But the way it updates other database management systems is asynchronous. That means DB1 might receive updates at time like t is equal to 1, but that doesn't mean DB2 will accept the same type of update at time t is equal to 1. It might receive at time t is equal to 10 or t is equal to n, where n is greater than 10, So for that purpose, it's asynchronous update enabled, but every node as a peer-to-peer database system can initiate or trigger update propagation over the distributed nodes. So when you see this one, it can succinctly describe what eventual consistency is. So in this case, this database system, the symmetric asynchronous replication enabled database system, is a database system that applies or that uses the symmetric asynchronous approach or the eventual consistency approach. That means it doesn't strictly ensure the same view of data at the same time over all database nodes, but eventually it will ensure consistency is obtained. Okay, so a good example for this one would be, for instance, social media back in the database, a database for social media. So usually some aspects of the social media databases does not have to be or do not have to be updated in synchronous manner. Okay, so for that purpose, for instance, let's assume it's a bit complicated thing, but for instance, say let's consider Facebook. When you have friends who follow you and friends who you follow, right? So whenever the user, your friend, posts something on his or her timeline, in case of strict consistency, you should be able to see those updates in your notification immediately. Okay, but since Facebook implements eventual consistency, you might not see such kind of updates on your timeline. It's more to application thing, but even if you consider it from the database perspective, you might not necessarily see the updates made by your friend until some point in time, which is defined by the system, or until you explicitly request update to your timeline with respect to your friend's timeline. Okay, this is what we call asynchronous symmetric environment, and this is what we call eventual consistency. So if the state of data in the same replicated database or network nodes should not necessarily be, the same every time, then we can implement eventual consistency. And there comes the idea of NoSQL. So here we can define NoSQL at this moment by saying NoSQL is a database management system or a database system in general that adheres to the eventual consistency requirement of distributed database systems. That means in NoSQL database system, you do not have to necessarily update all replicated nodes of these NoSQL databases, but eventually you have to make sure consistency is achieved, but asynchronously, eventually. So, for instance, in this aspect, when you see symmetric asynchronous replication, it might be, according to the CAP theorem or the conjecture suggested by the guys here, it might be AP okay, but C non okay. That means availability and partition tolerance okay, this database system, okay, but it might not be consistency okay. This is what we call eventual consistency. It doesn't mean, by the way, there is no consistency in this kind of database environments or in NoSQL database environments, but it means consistency is not ensured synchronously. That means consistency can only be ensured eventually or asynchronously. So that's why NoSQL is more to the base property rather than ACID property. I will talk about that one later. Okay, now let's talk about NoSQL. So when we say NoSQL, we are saying not only SQL, okay? Not only SQL. Can you show me your hand? Are you with me? Okay, great. Thank you. Thank you. So when we say NoSQL, it means not only SQL. Not only SQL. So basically, for us, it's better to think of NoSQL databases as a database system which is suitable for distribution, as a database system which does not adhere or conform to ACID property of relational database systems, but more to base property of relational database system. And the excuse it takes or it gives to be to ensure eventual consistency rather than ACID property or strict consistency is that the CAP theorem. The CAP theorem. According to CAP theorem, as I already mentioned, they say, or they came up with this conjecture theorem in which they say we can only achieve two of these three desirable properties. So they say any database management system cannot achieve these three at a time. So if it cannot achieve these three properties at a time, then there should be more emphasis to, availability, scalability, and then less emphasis for consistency. But this theorem might not be applicable for instance, update-sensitive environments. Update-sensitive environments, which are, for instance, say, banks, financial sectors, financial institutions, insurance sectors, or similar type of sectors. They cannot apply eventual consistency due to the nature of their transaction. But for most other sectors or domains of data and data management, I think eventual consistency is perfectly applicable. So NoSQL is not only SQL, and NoSQL databases are specific to different data domains, okay? And these are specialized data models. For instance, we can mention, for instance, key value type of stores or databases. Tabular databases can also be mentioned, but like tabular, like big table type of databases. Document databases like, say, MongoDB can be mentioned here. These are specialized data models. They are not all-inclusive, database management system, but specific to different natures of data. If you consider graph database, we do have Neo4j, for instance. Okay. So NoSQL database management system, as we already mentioned, it trades relational database management system properties. For instance, relational database management property is fully declarative, it's fully SQL, it ensures ACID transactions, it ensures data independence. But here, it's a little bit loosened. That means it's more to application-oriented access of data rather than SQL-based access of data. It's more to eventual consistency or base property, base transactions, rather than sorry. Okay, so it's more to base properties rather than ACID transaction properties. So it's more, data centric, but data independence is not achieved through referential integrity in NoSQL type of databases. So it's known for its simplicity, scalability and performance, and flexibility for the programmer. As you already mentioned, it's more the access of this kind of database systems is more related to how you access dictionaries or how you access, some kind of data structures in your application domain. So they are very flexible, they are easy to use, they are scalable, their performance is high, and it's simple structure-based database management systems. So the following are some of the data models, NoSQL data models in increasing degree of complexity or order of complexity. For instance, we do have key value store databases or key value based databases, tabular databases like Bigtable could be mentioned, document database, graph database, multi-model databases, or OrentDB like multi-model or PolyStore databases could be mentioned here, for instance. We can also mention XML databases and object-oriented databases, but the author of this book, the Ozusu, he says, XML and object-oriented databases are not NoSQL databases, because the main reason he provided was that object databases and XML databases are not that scalable as key value store databases or graph database or document database. Okay, so I really like to mention these databases as NoSQL databases because their complexity in representing data is different from relational databases. So maybe we can come up with this new subcategory of NoSQL databases, and we can say these object database management systems and XML database management systems are non-relational database management systems with an advanced components, that makes them suitable over relational database management system. For instance, one would be for object-oriented database system, for instance, or for XML even for that matter. We do have our databases, these object-oriented and XML database management systems have a high degree of capability to store complex data structures, okay, which cannot be provided by relational database management system. So we cannot simply categorize them under relational database management system, and also we cannot disregard them or isolate them from NoSQL database management system, but we can include them as NoSQL database management system with some setbacks or with some substrates that hamper their scalability. Okay, so I will not be discussing about each of this one because this is supposed to be presented by you. For instance, there is a team who will be or who have already worked on key value store databases, and also I'm expecting some more database specific demonstrations in the next consecutive classes we will have next week. So I will not be talking about what key value stores are. For instance, I will not be talking about what Amazon DynamoDB is, its type of key value store, but I will not be discussing about this one. The same is true for all other database systems. I'm not avoiding them, but I'm giving you the chance to present new concepts on your presentation session. Okay, if I present them here, then your contribution for this knowledge acquisition might not be that big, but I will let you. There are teams who will be presenting on document databases like MongoDB, DynamoDB like key value stores. Other types of databases are also there. So this will be presented in a separate session by you. So I will let you do that by yourself. I will not be talking about this one today. That's why I said we will be covering two major sessions today. The first one is a basic theoretical aspects of NoSQL database, but it will be extended by your seminar. Okay, that's one. The second one is practical session. So I will dive directly to practical session after discussing a bit about NewSQL and PolyStores. So we already discussed about what NoSQL is. Okay, it's a database management system or a database system which adheres to the principles of eventual consistency. It doesn't follow the basic relational database management system properties like ACID property. It doesn't adhere to the strong consistency requirement of relational database management system, but on contrary, it conforms to the major property of distributed database systems, which is scalability. And this cannot be acquired from relational database management systems or even centralized relational database management systems. But when we come to the other one, which is a little bit different from NoSQL, is NewSQL. So in case of, for instance, SQL-based relational database management systems, the good thing would be, from the relational database management system, the best thing would be the consistency, right? In relational database management system, you usually preserve the consistency of your database to its highest level. That's one of the advantages of relational database management systems. So from the transaction perspective, we can discuss about that. Even standard SQL structured query languages are also available, which makes it very easy to provide advanced tools like business intelligence tool, OLAP tools, such kind of analytics tools. Okay, is it a hand, Jonas? Is it raised for question? If so, please forward your question. I think Tananye Zergo, you are presenting something? No, it's not Tananye. Tananye, I think you are presenting. And are you guys የኔን ስክሪን እያያችሁ ነው? ኦኬ የኔ ስክሪን የሚታያችሁ ከሆነ ኢትስ ኦኬ አይደለም? ኦኬ እሺ ማን ነው መሰላችሁ? ተናኘ ስክሪን ሼር ያ someone okay this one አሁንስ የኔ ብቻ ነው የሚታያችሁ? Okay, just give me a minute. ተናኘ ምናልባት ጥሩ የሚሆነው ኖ ከኤግዚት አድርጊና ከንቱኑ ኮኔክሽኑ አቋርጭ ውጪና ኦኬ ቀላል መንገድ ነበር ሸት ዳውን ከማለት የሚሻል ኤኒዌይ ኦኬ እንደገና እንድትገባ ኢንፎርም አድርጓት ተናኘን አሁን የኔ ስክሪን ይታያል አይደል ኦኬ ያ ሳታቅ ነው ስትነካካ ያ ይገጥማል እንደዚህ አይነት ነገር okay so I was talking about NoSQL አይደል NoSQL ላይ NewSQL actually so NewSQL ለምን አለን we just said relational አለን ከዛ NoSQL አለን so now why NewSQL እያለ ነው so NewSQL is a database management system that takes the best aspects of both NoSQL and relational database systems. From relational database systems, it takes the most, interesting part of relational database, which is strong consistency, ACID transactions, okay, and standard SQL. So NewSQL is based on SQL, okay, which is different from NoSQL. The second thing, from NoSQL, the most interesting part were scalability, performance, okay, and also its proximity to programming or programmers because it provides practical APIs for data acquisition and manipulation, okay. So for that purpose, NewSQL is a database management system that aspires to build databases or to serve databases with high degree of scalability and at the same time with high degree of consistency, okay. So NewSQL is NoSQL and relational database hybrid database management system, okay. So there are different NewSQL database management systems which will be discussed by one of the teams among you, so we will attend to that presentation, so I will not also be covering specific aspects of NewSQL databases, but the most important part to conclude this chapter would be the PolyStores. So PolyStores are, multi-stores or multi-database systems. If you remember when I discussed about the architectures of distributed database management system, I discussed about multi-database systems. These are also called multi-stores or PolyStores, okay? So these PolyStores provide integrated access to multiple cloud data stores, okay? It could be, relational database management system on one side, NoSQL database management system on the other side, NewSQL database management system on the other side. So this is what we call PolyStores. So PolyStore is, most often it's a cloud database management system which provides heterogeneous types of data models, okay. So this is also another aspect of advanced database management systems, okay. So even, for instance, when I discuss about multi-database systems on the very first chapter or on the second chapter, I'm not sure. It's, I think, in the first chapter of our discourse. I started from client-server architecture, like standalone system, then client-server, then distributed, like peer-to-peer database systems. Then finally, I discussed about multi-database or PolyStores, okay? That the reason behind that is that PolyStores are even much more difficult than distributed database systems because PolyStores might have one node or one local conceptual schema representing a whole distributed database management system, okay? So multiple distributed database management systems can be subsumed under one PolyStore. That's the idea. So for that purpose, it's a bit difficult from distributed database management systems. And also it's, kind of under development research area. But most cloud vendors like Amazon, Azure, Microsoft, other database cloud vendors are still, providing such kind of database models or architectures. But for office use or for enterprise use, it's still under research or development sector, okay? So we already discussed about multi-database systems in the very first chapter of this course. So I expect someone from you to present this one too, about PolyStores, okay, since they are hybrid forms of database systems. So that's all I think. I think this details about what Hadoop, this kind of database systems is still subject for, seminar. I remember I listed Hadoop as one of the databases in the under the NoSQL database. So I think it's kind of framework actually rather than database, but I expect it to be presented. So በዛ ፕሬዘንቴሽን ሴሽን ላይ እነዚህ አሁን ዝም ብዬ ጃምፕ ያደረኳቸው እንደዚህ ያለፍኳቸው ዳታቤዝ ፍሬምወርኮች ፖሊስቶር ወይ መልቲ ዳታቤዝ ፍሬምወርኮችን ኢን ዲቴል ፕሬዘንት እንደሚደረጉ ኤክስፔክት አደርጋለሁ። ለዛ ነው ልክ ክላሱንም ስንጀምር ሴሚናር 2 ስፔሻሊ እዚህ ላይ እንዲያተኩር ያደረኩት። one aspect of this is more to distributed database systems ነው። ሌላኛው aspect of this course ደግሞ ምንድነው more NoSQL databaseዎችን አሁን ለምሳሌ Hadoop, Spark አይነት database ፍሬምወርኮችን የፖሊስቶር ፍሬምወርኮችን በዛም እና MongoDB ሌሎቹንም በደንብ አውቀን መውጣት ስለሚኖርብን ይሄንን በሙሉ በአንድ ኮርስ እንዴት አድሬስ ማድረግ እንችላለን የሚለውን ስናስብ the only best possible option ምንድነው ሴሚናር ነው። ለምሳሌ if I want to make them a chapter, then I would have like 50 60 chapter ሊኖረኝ ይችላል for each of these NoSQL databases. Again, if I categorize you with the types of NoSQL databases, and if I ask you to come up with something to read and also something to convey as a demo, then that will address many things ማለት ነው። እና ከዛ አንፃር I think ጥሩ ነገር ከዛ ሴሚናር ሴሽን ምንወስድ ይመስለኛል። ሴሚናር ሴሽኑ መቼ ይጀምራል? ኔክስት ዊክ ይጀምራል። ኔክስት ዊክ ትንሽ ኢንተንሲቭ እናደርገዋለን። በአንድ ቀን ማታ ነው የምንገናኘው። I think I don't know እስቲ ከነ ብርሃኑ ጋር እና ከነ ዳኜ ጋር አወራና የሚመቻችሁን ያማክሯቸዋል። ኦኬ then ሁለት ቀን ከዚህ በኋላ የምንገናኘው ለፕሬዘንቴሽን ነው የሚሆነው ማለት ነው። ሴሚናር ላይ አንድ ሳምንቷን ሴሚናር ላይ እናሳልፋለን። I was planning to show you እንትን ግን I think we should postpone it to some other